Next up, we've got Silvia Durisova, who's going to be talking about hyperbolic meteoroid orbits for meteor observations and interstellar meteoroids. And you've
Hello,
got
everyone.
14
My name is Silvia Durisova. I am a PhD student from Astronomical Institute of Slovak Academy of Sciences. So we will be talking today about hyperbolic meteors. So what to know? There were far too many hyperbolic meteors in the past in the databases, and they were actually thought to come from interstellar particles, from interstellar meteoroids. However, as the quality of the data progressed, the quantity of the hyperbolic meteor orbits became lower, and what was left was considered to be the result of errors. However, nowadays we do know that there are some particles from interstellar space, even in our solar system. We have observed Oumuamua and Borisov in 2017 and 2019 passing through our solar system. And we do know of the presence of interstellar dust from the local interstellar cloud. However, there are no cases of interstellar meteoroids that has been confirmed and unanimously accepted. So let's look at the state of the databases and the hyperbolic orbits within. For this, we will use what my colleagues and I call Kresak's diagram. The idea came from Kresak and Kresakova paper from 1976. And I visualized it using the CAMS database. I need to stress that this is unfiltered data, so some things are very nice to show in it. And it is the Kresak's diagram shows the relationship between the geocentric velocity and the elongation of meteor's geocentric gradient from the Earth's apex. So you can visualize the whole database and you can look at its quality. I have visualized the parabolic limits, and what it means is that everything below this parabolic limits belongs to the ecliptic population, ecliptic orbits, and everything above this line suggests hyperbolic orbits. You can see the nice spreads beyond the parabolic limits on this unfiltered data. And let's see what it means for individual cases. So let's pick a random point or random meteor. I need to stress that this is really a random hyperbolic meteor. It is not a suggested interstellar meteoroid. In fact, there were no that I know of suggested from the GAMS database. And so let's assume that this is a hyperbolic meteor which became hyperbolic due to errors. So to shift the hyperbolic orbit into an elliptical one, you need to have geocentric velocity error about 18 kilometers per second, or you can have actually the error in the radiant positions, that would be 60 degrees. In both cases, these errors are quite big, but it is assuming that it's error only in one parameter. But you also can have the combinations of errors, so geocentric velocity and in the radians, so the elongation, which means we are looking at these blue arrows. This means that these errors might be lower when you combine them. This is just a hypothetical case. So let's somehow combine this hyperbolic population with interstellar one, or supposed interstellar one. So what we think we would see if we have been able to observe a bunch of interstellar meteoroids, that would be that their velocities would copy the velocities of the stars from the solar neighborhood. So on this graph, I have drawn a median velocity of the solar neighborhood with this green one. It equals to 22.5 kilometers per second of arrival velocities. So if we would see a real interstellar population, they would be somewhere along this line. Just for the illustrations, I have also calculated what it would be like if there was some meteor with the arrival velocities equal to Oumuamua or Borisov. So the velocities were the arrival velocities were 26 kilometers per second and 32 kilometers per second. So those are represented by these black lines. So they would fall somewhere here. And of course, we do have hyperbolic meteors around these lines, but they are mostly the continuous spreads from the ecliptical populations beyond the parabolic limits. It looks kind of scary to look at it this way, but you need to realize that there is really a lot of points, and the bulk of this distribution is below the parabolic limit. Let's switch the databases. Let's see what global meteor network looks like. And just to make it clear that the bulk of the distribution is really below the parabolic limit, I have made the density map for this, but you can see that there is really that spread beyond the parabolic limit, even here with the higher velocities around where we expected this median is. But you can look at it that these higher velocities also mean bigger error. And when you look at simple distributions of real GMN data, that's here on the right side, the blue line, you see the continuous spread in the distribution of heliocentric velocities. And with the orange, I have visualized a rough representation what interstellar meteor population might look like. It is quite sensitive to the which catalog you actually use and which selected star you take. And it is scaled to represent the number of hyperbolic meteors which are in the GMN database. The GMN database has about 8% hyperbolic orbits, 1% if you do some quality selection, if you filter it a little bit, but this is just for illustration. There are no errors included. It is quite clear that this population can be real interstellar population. And just to look at a few more databases, on the left we have Edmond database, and I've just picked four subset of the database to see a little bit the relation between different parameters and how they are visualized on the graph. So you can see the tricky ones are these with lower perihelion distances. And on the right, there is the example of data from European Fireball network. This one's actually quite nice. You do not have anywhere this really big spread beyond the parabolic limits, except for a little bit these at the higher geocentric velocities, but they are easily filtered out when you look at the error analysis. So this is quite good, and you see there is nothing when we would expect the possible interstellar population to be. Another thing you can look like is if you trace this orbit, if you find the asymptote and look where they could possibly come from. So here we again have data from CAMS database. And after a bit of filtering, removing the shower meteors and so on, you can see that really there is the big, the main of the distribution is here around the ecliptic, where we would actually expect to have population from our own solar system, and there is really nothing in the directions where we know the interstellar object came from. So from the directions where Oumuamua and Borisov came from, or from the solar apex. So if you really want to see some interstellar meteoroids, we should probably pick the pick a good database with good data, with underestimated errors. A way to do that is to check the data with Kresak's diagram, because it's useful for checking the quality and the error estimation. But in most databases, it is not possible to actually identify the interstellar population, and we cannot see that there is any real bigger populations in these databases. So just my references. Thank you very much.
All right, thanks, Silvia. Do we have any questions in the room first? No questions. I'll check online quickly if there's anybody there. Right, so I had a question. So it looks like the technique you've developed is really good at identifying those kind of, I guess, promising outliers. So do you reckon it'd be a worthwhile endeavor to like remeasure some of those like particular like weird looking orbits? Because yeah, most of them are probably measurements error, but we might get lucky that one of them might be actually interstellar or actually hyperbolic to start with.
Yeah, you might be lucky, but it's a little bit tricky, because most of them, especially considering if they come from some databases which do have these spreads, I would actually check quite vigorously, maybe run them through run the raw data through another system, and look if there is something wrong, because it can be just the processing of the data. So yeah, it needs to be on individual basis.
Probably is, yeah, mostly measurements errors. Just
Yeah.
maybe not too many like specific events to look through to go back to the raw, I guess, the raw images and remeasure, and those potentially be the most kind of like interesting targets to look at for finding interstellar objects. Galina had a question as well. Go ahead.
Yes, please. As far as I know, searching databases went to nothing in practically no cases. Could we do something opposite? For example, to plan experiment, to plan observations, I don't know, ground observations, space observations, which could find such meteoroids with more high probability.
Okay. I'm not sure about the observations. I wanted to do some simulations to see where they would fall, the individual cases on the Kresak's diagram. But I'm not sure. There are some spaceborne observations from the satellites, but these actually are worse than the ground observations. So I would say the best thing is just to vigorously go through data, and I think it needs to be case by case basis.
Thank you.
Right, there's no more question. Let's thank Silvia again.